Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study the new graph called discrete time real exponential sequence. Now we have studied the continuous time exponential sequence in previous videos also. Now discrete means what? The exponential function or exponential signal is available in the sampled form. Now how it looks we'll study first, and then we'll see the effect of time period or time on the exponential graph. We'll see one by one. I've chosen one function that is exponential, and in order we have placed minus of mod of n. You can place minus n also or not, it's your wish. Now there is no logic behind the minus n. I have just placed that minus n for a sake. Now mod of n means what? That n value can have, or maybe it is positive or maybe it is negative. So according to that, the whole amplitude, that is this minus sign and with the value of n, will changes the graph. How? We'll see. So first of all, this is the plot. In this case, I have not selected a negative side. I just want to show how exponential graph flows, and but in discrete manner how it looks. So for any values of n, maybe n is positive or n will be negative, your graph will show two types of graph, maybe decaying or rising. So how it looks: a decaying exponential and rising exponential. Decaying means what? Your graph is gradually or exponentially decreases and reaches to value 0 at infinite time. Similarly, rising means what? Your graph will continuously increasing its amplitude exponentially, and at infinite duration the amplitude will reach to its infinite level. So in x of n, like in this graph, what we are going to do is, I just want to represent a discrete exponential graph with rising and exponential signals or sequence. So rising sequence, I'll plot this rising sequence by different pen. We'll use different ink for let's say the time sequence is 0, 1, 2, 3 and so on, and for this sequence I'll draw the graph. First of all, I'll plot the graph using this ink pen red ink, and the graph I want to show is decaying. Decaying means what? Your amplitude is continuously goes on decreasing. So at n equals to 0, if I substitute n equals to 0 over here, if I substitute n equals to 0 over here, e to the power 0 becomes 1. Means what? At n equals to 0, this function is having amplitude 1. So let's say this one is the amplitude, which is 1. Now as I said, the function is exponentially decreases its amplitude. Then at n equals to 1, that amplitude will be like this, and it will goes on continuously decreasing in exponential manner. So as you can see, this graph is exponentially decreasing, and these are the amplitudes of graph. Now similarly, this is the decaying exponential, and now I just want to show the rising exponential. Rising means what? Your amplitude is continuously goes on increasing. So goes on increasing means what? How the graph will look like. I'll plot that graph once again. Rising means your amplitude is continuously goes on increasing. So let's say the time sequence is 0, 1, 2, 3, 4 and so on. And now rising means your amplitude is increasing. Means what? Let's say at n equals to 0, as I discussed, n equals to 0, amplitude is 1. Similarly for this 0 also, your amplitude is 1. Let's say your amplitude is 1 over here. I'll just overwrite this so that you will understand the graph, how to plot this graph. Similarly over here also. Now for n equals to 1, as I said, this graph is rising, means what here, for n equals to 1, graph amplitude will goes on increasing but exponentially. So now you can see here, the amplitude of this graph increases exponentially, and these are the amplitudes of function. This graph is for a rising exponential. Now you will say this is only a positive period. If you ask how this graph looks like if we choose the period from minus infinity to plus infinity, then I'll show you how this graph will look. Now what I'm going to do is I'm just going to substitute the values of n from minus infinity value to plus infinity, just to show that how the decaying and rising exponential looks like, but in discrete format. So the function of x of n is, again I'll write the same function, x of n is equals to e to the power minus of mod n. This was the function that we have selected. Now let's say first case, I'll choose your n value is negative, or I'll say n value is less than 0. Less than 0 means that is n is having negative values. So for negative values, this function is represented like x of n is equals to e to the power minus of minus n. So the power of e will be plus. Now we'll draw the graph for this. This is our x of n, and we'll take the few samples which is near to 0, and using that also you will get the idea. And so on. Now for n equals to 0, if I substitute n equals to 0 in this function, if I substitute n equals to 0, then x of 0 is nothing but e to the power 0, and e to the power 0 is nothing but 1. Means what, at n equals to 0 your amplitude is 1. Similarly for n equals to 1, your function will have amplitude that is e to the power 1, and this e to the power 1 will calculate. Now for e to the power 1, what you will get? So I will calculate the value that is for e to the power 1, and the value is something you will get. The value is 2.718. Now similarly I will calculate the value for x of 2, that is n equals to 2. For n is equals to 2, the x of 2 will give amplitude, or the power of e will be 2, and for that you will get the value which is 7.389. I'll do the same thing for n equals to 3. For n equals to 3, this x of 3 will be e to the power 3, so therefore your x of 3 value is 20.08. So just look at here, when n equals to 0, this function will get the value 1, or you can say the function is having value 1. Similarly, for n equals to 1, this function is having value 2.718. So for n equals to 2, what do we have, or what we'll get? X of 2 equals to 7.389. Similarly, we'll calculate the value for n equals to 3, and we have the value that is 20.08. We'll calculate the next values also for n equals to -1, -2 and -3. So what we will get, I'll note it down fast. So for n equals to -1, what I will get? 0.03367. Similarly, for n equals to -2, what we have? 0.135. And for n equals to -3, we have 0.049. Means what? Now you can say that your amplitude of this graph after a 0, or you can say in a negative sequence, it almost reaches to 0 value. So we'll draw the graph first. So we'll start from the highest one, that is n equals to 3. So for n equals to 3, we have value 20.08. So let's say this one is the point where we'll get the value of, which is 20.08. I'll mark it over here. Next, similarly for n equals to 2, what you will get? 7.389. So for n equals to 2, my value is 7.39. So let's say this one is the point where you will get the value, which is 7.389. And for n equals to 1, we have value, for n equals to 1, we have value 2.78. That is, let's say over here, 2.718. No need to use scale. You can approximately draw this graph. The same thing I have drawn, the same thing I have used. N equals to 0, my amplitude is 1. So let's say amplitude is 1 over here. And but at -1, -2 and -3, what we have? For -1, 0.0367. So let's say this is the value where you will get 0.367. Similarly, for n equals to -2, what you will get? 0.035. So let's say it is over here. And for this n equals to -3, what will you get? 0.049, which is almost over here. That is, this value is 0.049, and this value is it's 135. So if we connect these points, then what you can see is this graph is exponentially increasing. You can just look at here, your graph is exponentially increasing, and so on for next future values. So this graph is nothing but rising exponential. Sequence, but in discrete time. Now this graph is for rising exponential. We'll do the same thing for decaying exponential also. Now, so how it looks, we'll see. So for decaying exponential, the graph is similarly, or it looks like decreasing. But first of all, I just want to do some changes. In previous case, what we have selected, the n value is negative. Now right now I just want to substitute n value positive. So what we have done, or what we have choose, x of n function is minus of mod of n. This was the function. Now for, in previous case we have selected n value is negative, but in this case, that is, let's say part number 2, in this case my n value is greater than 0. That is, my n is having positive values. So if n is positive, then this function becomes x of n is equals to e to the power minus of n. and we are going to substitute values of n in this function. So how this graph will change its behavior, we'll see. So first of all, we'll draw the x-axis and y-axis. Minus n to n. This one is 0. Let's say here we have minus 1, minus 2, minus 3, and so on. Similarly, on the right hand side, we'll write 1, 2, 3, and so on. Now, on y-axis, I'm just going to write x of n. So, we'll calculate the values of this sequence first, and we'll let you know how this graph will look like. We'll start from n equals to minus infinity, which is the leftmost bit, and we'll end up at n equals to infinity, which is the rightmost value of n. So I will calculate that value first, and then we'll go for graph. So we'll substitute the value of n equals to infinity first. So for n equals to infinity, minus infinity, the value is we know that e to the power infinity is infinite. So for n equals to minus of infinity, this x of n is having value infinity. Now actually basically we have to substitute this value over here, but I have not placed. We'll do it from this time. For n equals to infinity means what? I have chosen, or I have selected the leftmost side of this graph. So, and for that we'll have infinite amplitude. So for leftmost bit I'll get infinite value. Similarly, we'll calculate the values of minus 3, minus 2, and minus 1 one by one. So for here I'm going to write x of n. I'll make some columns, and let's say this one is for x of n. So for n equals to minus infinity we have calculated already. So for minus 3, minus 2, and minus 1, what are the amplitudes? We'll see. So for negative values, what I will get? For minus 3, the amplitude is highest. For minus 2, this amplitude is 7, and for minus 1, the amplitude is 2.78. So let's see these at minus 3, the amplitude is 20.08. So I'll draw it over here. Let's say this is the amplitude for minus 3, and the amplitude is 20.08. Similarly, we'll do the same thing for minus 2 also, and that amplitude is 7.389. So let's say this one is the amplitude 7.389, and at minus 1 the amplitude is 2.789. So let's say this one is the 2.718, and for n equals to 0. Now for n equals to 0, what you will get? As I told you, if I substitute n equals to 0, e to the power 0 is having value 1. So let's say at n equals to 0, we'll get amplitude which is 1. Now for further calculation, that is for n equals to 1, n equals to 2, n equals to 3, what you will get, or what will be the value of x of n? We'll calculate it first. So for n equals to 1, the value is 0.367. For n equals to 2, 0.135, and for n equals to 3, the value is 0.049. Means what? At this stage, you can say that your value is approximately reaching to the x-axis. So I'll draw the graph first. For n equals to 1, you have the value which is 3.367. So this one is the value of 0.367. For n equals to 2, the graph having amplitude over here, and for n equals to 3, this is the place. I'll write down this value over here, 0.135, and for n equals to 3, this value is 0.049. If I'll connect all the points, then what we will get? So let's connect all these points one by one. I have already connected all these points. So what you can see, this graph is continuously decreasing and the amplitude is also continuously decreasing basically. So this type of behavior of this exponential wave or exponential sequence is called as decaying exponential. So this is our decaying exponential sequence, but in discrete format. Thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda for further videos. Thank you.